Please. Good afternoon, everyone. I'm Tzu-Ching Kuo, and my advisor is Dr. Yanfu Guo. I'm from National Taiwan University, and today it's my pleasure to be here to share with you my research. And my research is detecting cell insect by yellow V5. So first of all, I want to talk about what is scale insect. Scale insect is a common pest in agricultural industry, and mostly seen on plant and fruit. However, when a scale insect appear, it normally coming with a negative effect. So what kind of effect will it occur? So we have to talk about the scale insect. The scale insect, when they want to suck sap, they will use their mouth pads to penetrate the peels of the plant and fruit, and this will cause wounds. And the wounds will let the bacteria and virus or fungi to infect. So after infection, the plant will get illness and even die. So at the leftmost image, you can see this is a pineapple tree and get a mealybug wilt. And to get mealybug wilt, the plant will get wilt and die. And in the middle image is the pears, and the pears also get infected by the scale insect and cause the red color discoloration. So mercifully, the scale insect may kill plants and fruit. If not, they can still make plants and fruit inedible for human, or not just good appearance. Any of the above result can damage farmers' profit. Furthermore, scale insect infect plant and fruit can be banned from export and import, and finally cause economy loss for a nation. Because of suitable climate, Taiwan is reaching fruit. So we can see the production value of produce, the fruits have account for 36.3%. And in the 36.3%, the export have account for more than a half. And this shows that Taiwan are highly dependent on export. However, in recent years, our fruits are rejected due to scale insect infection, and this caused a lot of economy loss, not only for the farmers but also for the nations, and also raised the government awareness. Traditionally, when we're trying to export our fruit, we use the human force to inspect whether the scale insect on the fruit or not. However, in a modern society, the human force are very expensive, and also the time is very precious. So a time-consuming and laborious method are not recommended. Also, the human have subjective criteria and fatigue issue. So it's very important we have to solve this. So in this project and in this research, we're trying to implement the CNN, convolutional neural network, to solve this problem, to let computer decide whether the scale insect is and how much it is. And we have construct a model and system prototype for us to detect the scale insect. This is the automatic detection system prototype. Just you can see, and this is a webcam, the camera that the user can control it to capture the image, and the image will be sent to the convolutional neural network, and the network will send back the result for the user on UI. This is how the UI looks like, and in the present stage, I only developed a Mandarin version, and the model will send back the image with the scale insect detect result and shows how many scale insect on it. And we have two modes, image mode and camera mode. A camera mode, just like the former I've mentioned, the user can control camera. And the image mode means that the user can choose their own image to detect. So these are target fruit. So I trained 3 models for these 3 fruit. So the reason I will explain later, and in present stage, I only have tackled these 3 fruit scale insect issue. This is the scale insect on the data looks like. As we can see, the lemon scale insect are apparently different than others. And it is so that is one of the reasons I will choose to train 3 models rather than 1. Okay, So let's talk about the data set. The pineapple data set. The pineapple data set have one image size. And the number of image have 922. The training and validation data set has split by the ratio of 7:3. This is how the data set looks like. So because the scaling set will be camouflaged with the complicated texture and the wax on the pineapple, so we decided to take more closer and more detailed images for model to learn. This is the CIGR apple dataset, and also have the same training and validation ratio. However, you have the different image size. They have two image size. One is the 4:3, and another is 1:1. So the aspect ratio after the resizing might be different, and I will tackle this problem after. And this is the dataset of the CIGR apple, and due to the clean peel surface, I decided not to have the closer images, just have the entire fruit as a method. And this is the lemon data set, and also have the two image size. One is 4:3, another one is 60:9. And the images is the list, only have 124 images, and have the same training and validation ratio. This is how lemon dataset looks like. So this time I choose YOLO V5 as my deep learning model. So the deep learning model, the YOLO V5 is a famous object detection model, and also have a very strong team to maintain it, and also easy to install and use. So as the above mentioned, I have talked about the severely small object, also have the different aspect ratio. So I crop it three kind of fruit, no matter the size, original sizes. I crop it the image to the pixel 2646 times 1492. So every picture will be cropped at the ratio like this. So this can not only prevent the spatial change, but also can prevent during the resizing into a model, and the convolutional process and pooling process will lead to feature loss. So this process has mainly enhanced the precision of the model. And these are the data augmentation I've done: photometric distortion, geometric distortion, mosaic, and copy paste. So in this part, I'm going to talk about my result. So the epoch I've chosen is 300 epoch, and is recommended by the official. So the image size I have choose to resize is 1280 times 1280. And the model I have choose is at 67 epochs, and have the precision 74.4%. And the reason why I choose the epoch 67 is because after the 70 epochs, the model started to have the serious overfitting, so the model is not good for us. So I choose the 67 epochs. Another one is CIGR apple. The CIGR apple have the best precision at the 176 epochs, and have the precision of 84.5%. Next is the lemon model. So lemon model have the best performance. However, due to the small data set, the data set it only have 125 images. So the data set is small, and the model is not robust enough. So even though the precision is good, the object loss cannot be converted. So in the future work, we are trying to extend the data set to get more and get better performance. So in this stage, I'm going to talk about the model performance. So in first part is pineapple. So that look at the upper left part, the image size, magnified, and exact meaning. Image size is mean the left image size, and the magnified mean the right image size. And the magnified image is cropped from the left side blue bounding box. I magnify it. And the insect is in the right image, the yellow bounding box. So as we can see, the insect are very tiny. They only have 22 times 34 pixels. So after resize and convolution and pooling, the features might be merely disappeared. So model is hardly learned. So it's easy to lose this detection. The other thing is also the pineapple. In this case, the pineapple recognize the round object as the scale insect. The model recognize maybe a leaves or a spikes on the pineapple as a scale insect. So maybe I guess it's a annotation problem, and I will discuss at a later. The next discussion is costar apple. So I want to talk about the blue bounding box one. The blue bounding box one is ambiguous one, and I have consulted with the expert, and the expert also cannot give me a very confirmed answer because the images, because the object is very small, and also for blur with low resolution, it's very difficult for human to recognize it, whether this is insect or not. So difficult for the model. And this is the most important discussion in this research because of we have a group of annotator, and also we have created a group of annotator with expert to discuss ambiguous cases. However, we are not expert. So when we try to annotate the scaling set, we might be misled by our judgment. Also, every people have their own criteria. So when they try to annotate, they might have different decision on the similar situation. So the model are hard to learn on the inconsistent annotation. So last one is a fatigue. And the fatigue issue is about a same annotator. The same annotator, when they are fatigued, they might have different criteria. It might be a wrong judgment. So it also causes inconsistent annotation. And when we use the object detection model or use convolutional neural network or artificial intelligence, the consistent scoring truth is very important. So these issues or these problems are not good for the model training. So the conclusion is I have constructed a model prototype system using the convolutional neural network ULV5 to detect scale insect. And the results are on the screen. So I think and I infer the bad performance are about the accurate annotation. The last part is acknowledgement. I want to thanks for my lab mate and appreciate my teacher and appreciate the members in Taiwan Agriculture Research Institute. Thanks for having.
Thank you. Are there any questions or comments? Please. Yes, please.
Thank you for your excellent presentation. I'm just curious, are you interested in localizing the insect? Like, do you want to detect where the insect is in the object exactly?
Yes, I will locate the insect. Where is it?
What is the importance of that to your work? Like, why do you want to get exactly the position of the insect?
So in traditional method, we will use the air gun to blow the insect away. So, and we are trying to know where the insect is, and we can use the air gun to clean it. So we have to know where is it.
Oh, thank you.
Are there any questions or comments? Yeah, and I understand that most of difficult one is pineapple. Do you have any idea to improve detection accuracy?
Detection
in the
accuracy
next
improve.
step.
Yes, first of all, I think I will. The annotation is a more serious problem I have to tackle. So I will I will cancel the group annotations, the policy, so let only one person to do the annotation.
Okay.
So also, maybe we can find an expert to be an annotator and not a student or other people to improve the annotations quality.
Thank you very much. So time is up. I'm sorry. So thank you very much for your excellent presentation. The next 4 presentations will be done via the internet. So the next